Introduction. Welcome to this presentation on AR design principles. Augmented reality, AR, is a technology that overlays digital information onto the real world, creating immersive experiences. In this presentation, we will explore the fundamental principles of AR design, including objectives, overlaying digital content on the real world, how to seamlessly integrate digital objects into the real environment, contextual awareness and interaction design, designing intuitive and engaging interactions with AR content. Outline. To delve deeper into these topics, we will cover the following: alignment and registration, occlusion, lighting and shading, depth perception, real-world anchors, gesture-based interactions, voice commands, environmental cues. To create truly immersive AR experiences, we must ensure that digital content seamlessly integrates with the real world. One crucial aspect is alignment and registration. Digital objects must be accurately placed in the real environment, without any noticeable misalignment. This can be achieved through techniques like camera calibration and feature-based tracking. Alignment and registration. Explanation of the importance of accurate alignment. Accurate alignment is crucial in XR to create a seamless and immersive experience. When virtual objects are precisely aligned with real-world elements, it enhances the sense of presence and realism. Misalignment, on the other hand, can disrupt the illusion and lead to a jarring and disorienting experience. By ensuring precise alignment, we can create more believable and engaging XR applications. Visual examples of good and bad alignment. Let's take a look at some examples of good and bad alignment in XR. In a well-aligned scene, virtual objects appear to be seamlessly integrated into the real world. For instance, a virtual chair placed on a real-world floor should look like it's actually sitting there. In contrast, a poorly aligned chair might appear to be floating above the floor, breaking the illusion and diminishing the overall experience.
Snap to Reality automatically aligns virtual objects to physical constraints by calculating those constraints from the real world in real time. Our proof-of-concept system allows users to create, position, and scale virtual objects to be precisely aligned with physical edges and planar surfaces. Experiments confirm that such alignment is significantly faster with snapping, and that snapping enables a fresh form of AR content creation. We discuss Snap to Reality design considerations and more in the paper.
Techniques to achieve accurate registration. Camera calibration. Marker-based tracking. Feature-based tracking. Another key factor is occlusion. Digital objects should be correctly occluded by real-world objects, creating a sense of depth and realism. For example, a virtual object placed behind a real-world object should be partially or fully hidden, depending on the perspective. How occlusion enhances realism. Occlusion is a key factor in creating realistic AR experiences. When a real-world object, like a wall or a person, blocks the view of a virtual object, it adds depth and realism to the scene. For example, if a virtual object is partially hidden behind a real-world object, it creates a sense of three-dimensionality. This subtle detail can significantly enhance the overall immersion and believability of the AR experience. Techniques for achieving realistic occlusion. Depth sensing. Object recognition. To achieve realistic occlusion, we can employ techniques such as depth sensing and object recognition. Depth sensing allows us to accurately measure the distance between the camera and objects in the real world. This information can be used to determine which parts of a virtual object should be occluded by real-world objects. Object recognition involves identifying and tracking objects in the real world. By understanding the shape, size, and position of real-world objects, we can accurately render virtual objects that appear to be occluded by them. Lighting and shading play a vital role in enhancing the visual realism of AR experiences. Digital objects should have consistent lighting and shading with the real-world environment. By matching the lighting conditions, we can create a more believable and immersive experience. Lighting and shading. The impact of lighting and shading on immersion. Lighting and shading play a crucial role in creating immersive AR experiences. When the lighting and shadows of virtual objects match the real-world environment, it enhances the sense of realism and believability. For example, a virtual object placed in a brightly lit room should appear to be illuminated by the same light source as the real-world objects. By carefully considering lighting and shading, we can create more convincing and immersive AR experiences. Techniques for matching digital content to real-world lighting. Real-time lighting estimation. Real-time lighting estimation is a technique that analyzes the lighting conditions of the real-world environment and applies similar lighting effects to virtual objects. By capturing real-world lighting information, such as the direction and intensity of light sources, we can create more realistic and dynamic AR experiences. This technique is particularly useful for outdoor AR applications where lighting conditions can change rapidly. Pre-rendered lighting. Pre-rendered lighting involves creating detailed lighting and shadow maps for virtual objects in advance. These pre-rendered assets can then be applied to the real-world environment in real time, resulting in high-quality and realistic lighting effects. While this technique can be computationally intensive, it can produce stunning visual results, especially for static objects and environments. Finally, depth perception is essential for creating a sense of three-dimensionality in AR. Techniques like parallax effects and layering of objects can help to create a more realistic and immersive experience. The role of depth perception in AR. Depth perception is crucial for creating a sense of three-dimensionality in AR. By understanding the relative distance between objects, users can perceive the spatial layout of the virtual and real worlds. Techniques like parallax effects, layering objects, and stereoscopic rendering can help to enhance depth perception and create more immersive AR experiences. Techniques for creating depth perception. Parallax effects. Parallax effects simulate the way objects appear to move relative to each other as we change our viewpoint. In AR, parallax effects can be used to create a sense of depth by making virtual objects appear to move at different speeds as the user moves their head. This technique can enhance the perception of distance and spatial relationships between objects. Layering of objects. Layering objects involves placing virtual objects at different depths within the scene. By carefully arranging objects in layers, we can create a sense of depth and perspective. For example, placing a virtual object behind a real-world object can create a sense of occlusion, further enhancing the realism of the scene. Stereoscopic rendering. Stereoscopic rendering involves creating separate images for each eye, simulating the way our eyes perceive depth in the real world. By presenting slightly different images to each eye, we can create a 3D effect, making the virtual objects appear to have depth and volume. This technique is often used in VR headsets to enhance the immersive experience. Contextual awareness is key to creating intuitive and engaging AR experiences. By using real-world anchors, such as walls or tables, we can provide a stable reference point for digital content. This helps to ground the virtual objects in the real world, making the experience more believable. Real-world anchors. Using real-world objects as reference points. Real-world objects can serve as effective reference points for virtual content. By anchoring virtual objects to real-world surfaces like walls, tables, or floors, we can create a more grounded and believable AR experience. This technique helps users understand the spatial relationship between virtual and real-world objects, enhancing their overall immersion. Examples of effective real-world anchors. Effective real-world anchors can significantly enhance the user experience. For instance, using a table as an anchor for a virtual 3D model can make it appear as if the model is physically present on the table. Similarly, aligning virtual text with a real-world wall can create a seamless integration between the digital and physical worlds. By carefully selecting and utilizing real-world anchors, we can create more engaging and realistic AR experiences. Gesture-based interactions offer a natural and intuitive way to interact with AR content. By recognizing simple gestures like pointing, tapping, or swiping, users can control virtual objects and navigate the AR environment. Gesture-based interactions. Designing intuitive gestures for AR. Designing intuitive gestures is crucial for creating seamless and enjoyable AR experiences. Gestures should be natural and easy to learn, mirroring real-world actions. For example, a simple tap gesture can be used to select an object, while a pinch gesture can be used to zoom in or out. By carefully considering the user's perspective and designing intuitive gestures, we can create AR experiences that are both effective and enjoyable. Examples of effective gesture-based interactions. Effective gesture-based interactions can greatly enhance the user experience in AR. For instance, using a pinch gesture to zoom in on a virtual object or a swipe gesture to navigate through a virtual menu can provide a seamless and intuitive way to interact with digital content. Additionally, hand tracking can be used to manipulate virtual objects directly, as if they were real-world objects. By incorporating well-designed gestures, we can create AR experiences that feel natural and intuitive. Voice commands can provide a hands-free and efficient way to interact with AR. By recognizing spoken commands, users can perform actions like opening menus, selecting objects, or triggering specific functions. However, it's important to consider factors like noise levels and background interference when designing voice-based interactions. Voice commands. Benefits of voice commands in AR. Voice commands offer a hands-free and efficient way to interact with AR experiences. By simply speaking commands, users can navigate menus, select objects, and trigger actions. This can be particularly useful in situations where using hand gestures or touchscreens is impractical or inconvenient. Additionally, voice commands can enhance accessibility for users with disabilities. Challenges and considerations for voice command implementation. While voice commands offer many benefits, there are also challenges to consider when implementing them in AR. Noise levels, background interference, and variations in accent and dialect can impact the accuracy of voice recognition. It's important to design robust voice recognition systems that can accurately interpret user commands in various environments. Additionally, clear and concise voice prompts can help guide users and minimize confusion. Environmental cues can guide users through the AR experience. By using visual and auditory cues, such as arrows, highlights, or sound effects, we can direct user attention to specific points of interest. This helps to create a more focused and engaging AR experience. Environmental cues. Using visual and auditory cues to guide users. Visual and auditory cues can play a significant role in guiding users through AR experiences. By using visual indicators, such as arrows, highlights, or virtual objects, we can direct users' attention to specific points of interest. Similarly, auditory cues, like sound effects or voice prompts, can provide additional guidance and feedback. By combining visual and auditory cues, we can create a more immersive and intuitive AR experience. Examples of effective environmental cues. Effective environmental cues can enhance the overall user experience in AR. For example, using a subtle glow or vibration to indicate interactive elements can draw the user's attention. Similarly, a directional sound effect can guide the user's gaze towards a specific point of interest. By carefully selecting and implementing environmental cues, we can create more engaging and intuitive AR experiences. In conclusion, AR design principles are essential for creating immersive and engaging AR experiences. By understanding the importance of alignment, occlusion, lighting, depth perception, contextual awareness, and intuitive interaction design, we can develop AR applications that seamlessly blend the digital and real worlds. As AR technology continues to advance, we can expect to see even more innovative and impactful applications. From education and healthcare to gaming and entertainment, AR has the potential to revolutionize the way we interact with the world around us. I encourage you to explore the exciting possibilities of AR and to apply these design principles to create your own immersive experiences.